Flight testing campaigns are probably the most interesting phase in the development of a new aircraft. A decade or more of careful development and manufacturing lead to a first flight, followed by hundreds of tests in various conditions. Most times, these tests go well, a testament to the skill of the engineers at the various aircraft manufacturers. But in 2013, such a test flight failed when a new Sukhoi Superjet crashed onto the runway at Keflavik on a windy morning in Iceland. Let's find out what happened here. Welcome to Airspace. Let us first talk about aircraft development. Creating a new aircraft from scratch is tremendously costly and constitutes a major feat of engineering. Aircraft have to endure various harsh conditions, be it the cold air of the stratosphere or the searing temperatures on the tarmac of desert states, metal stress from bending loads during takeoff and landing, or just general daily wear and tear. After an aircraft successfully takes flight for the first time, the flight testing campaign begins. It usually takes a year or more, involving hundreds of flights and thousands of flight hours with the new airframe. In the end, should all tests be completed satisfactorily, the new aircraft will receive its type certificate. After that, it is ready for sale to customers. But certification does not stop there. Most of the times, additional features such as automatic landing capabilities are only proven at a later stage, requiring more certification flights. The accident we are going to take a look at today happened during such a certification flight. In the early morning hours of July 21st, 2013, a Sukhoi Superjet 100 was performing flight tests at Keflavik, Iceland's international airport. The purpose of these tests was to demonstrate the aircraft's automatic landing capabilities in various conditions. After having performed already 8 different tests during their flight, test number 9 should have been as follows. The crew would fly an automatic approach using the autopilot, simulating an automatic landing, all while the wind is blowing at a crosswind of 20 knots, that is 37 km per hour or 23 miles per hour. At 25 feet just before touchdown, however, the pilot on the rear seat would switch one engine off, simulating an engine failure. Then, a go-around on one engine will be performed. Yes, a go-around with one engine is cumbersome, but possible. The 3 pilots, all very experienced test pilots, prepared for the approach to runway 11 in Keflavik, while the wind was perfect for the test, blowing across the runway at almost exactly the specified speed. At 25 feet, the test pilot on the rear seat switched the right engine off, simulating an engine failure. To simulate the very worst case, the pilot flying also disengaged the autopilot to imitate an autopilot failure. So far, the test was executed perfectly. Now, the next point on the list would be for the pilots to go around. In order to do so, the pilot flying pushed the toga buttons. These are the take-off go-around buttons on the engine control levers. Pushing these will tell the automatic thrust system that the pilots want to go around and that full thrust should be commanded on whatever engines still remain. However, just as the captain pushed the buttons, the plane touched the ground very briefly, just for 0.4 seconds. This, however, was long enough for the landing gear computers to sense that the plane had touched the ground. This, by design, deactivated the automatic thrust system, and therefore also the command to deliver maximum thrust. This might seem unwise, but it is actually a design requirement for civil transport aircraft. Imagine if somebody inadvertently pushed these buttons while trying to park their aircraft and the engine started spooling up to takeoff power. Not a good idea. If all this sounds familiar, it's probably because this was a factor 2 in the crash of Emirates 521 in Dubai. A few moments after pushing the toga buttons, the pilot flying realized, however, that the automatic thrust system did not deliver any thrust, and therefore he immediately advanced the right thrust lever himself, thereby asking the engine to provide full thrust manually. He also called for the landing gear to be retracted and pulled up the nose to the go-around attitude. The aircraft climbed to 27 feet, but stopped its climb there and slowly started to descend. Baffled, the pilot now looked at his hand controlling the thrust lever. He had inadvertently advanced the thrust lever of the right engine that had been shut down just before touchdown. The lever of the left engine, that was still running, remained at almost idle. He had mixed up which thrust lever must be advanced for go-round. Realizing his mistake, he now applied full thrust on the left engine, but it was too late. The aircraft crashed onto runway 11 with its aft fuselage first, then with the engines. It skidded along the runway and came to stop on soft ground after the end. Luckily, no fire erupted and the pilots as well as the technicians monitoring the test flight in the cabin tried to evacuate the badly damaged aircraft. However, when they opened the first door, the emergency slide did not deploy. It had not been armed before departure. The crew then armed the slide of the door on the opposite side, opened said door, and the slide deployed. However, due to the strong wind, the slide was blown under the aircraft and was unusable. Lastly, the crew tried the rear downwind exit and were finally able to exit the Superjet. Only one crew member was slightly injured in the ordeal. The Icelandic Transportation Safety Board, which in Icelandic by the way is named like this, immediately started an investigation into the matter and found many interesting aspects to this case. The pilots, all very experienced individuals, had met up for the first briefing at 8:30 in the morning of July 20th, with the intent of flying tests from 2 in the afternoon until slightly after 11 in the evening. However, due to various reasons, the schedule for the test flights had to be moved several times, and after the 5th revision in one day, flying was to be performed from 7:40 in the evening of July 20th to 6:20 in the morning of July 21st. The crash therefore occurred 20 hours and 53 minutes after the flight preparation had started, and 10 hours and 53 minutes into the flight testing. By Russian laws, flight testing time must not exceed 8 hours. By operating this long, the pilots violated not one, but several flight time limitations. According to the investigators, the pilots were in a state of severe mental and physical fatigue when they were interviewed after the accident. Flying while fatigued is not easy at all, and it bears several stark risks for aviation safety. As I explained in my last video where I analyzed the near miss of Air Canada 759 in San Francisco, cognitive skills degrade severely and progressively as time passes. After 18 hours of being awake, one's reaction time is about equivalent to the reaction time one would have with a blood alcohol content of 0.05%. At that level of alertness, many countries prohibit driving entirely. The Icelandic Transportation Safety Board went even further and attempted to model the possible alertness of the crew after their long duty period. They calculated that the task performance of the crew would have been impaired by approximately 46% at the time of the accident. When the investigators asked the captain why he had agreed to violate the maximum flight duty times, he stated that he knew that the successful completion of the tests was crucial to his employer, and that he also knew that the weather would not have been favorable for flight tests during the coming days, so the flight tests had to be completed on this very day. He finds himself in good company among the many individuals who have tried to achieve a goal at any cost without considering the risks of his actions. The investigation also uncovered some other deficiencies, such as the operation and design of the emergency escape slides. First off, these slides should have been armed prior to departure, a thing that the crew either omitted or forgot. Second, the board found that the slides that were installed did not conform to industry standards. Such escape slides should remain stable in wind speeds up to 25 knots. On the day of the accident, winds were at around 18 knots only. Therefore, the board advised Sukhoi to redesign these slides. And lastly, the investigation also noted that Keflavik Airport allowed flight tests to be conducted on runway 11 during nighttime. This would not have been allowed under the official rules of the airport. Also, during the go-round, it would have brought the aircraft, which was at almost maximum landing weight at the time, with one engine shut down at a strong crosswind, with a severely fatigued crew and no safety oversight, over a populated residential area. In the end, the board stated the most probable cause of the accident to be severe flight crew fatigue. Unfortunately, this case is just one of many results of corporate pressure and strong pilot fatigue. Though in this case, the fatigue would have been mitigated by legal limits, but those were unfortunately ignored by the pilots. The aircraft, even though it looks ready to be scrapped in these pictures, was repaired and returned to service 5 months after the accident. It was never sold and remains in Sukhoi's property as a prototype aircraft. And that was the story of Sukhoi 97005. Check out my other video about Emirates 521 that crashed in a very similar manner in Dubai a few years ago. If you like the channel, please consider leaving a like and subscribing. See you all in the next one.